Good afternoon, ladies and gentlemen. It's January 27, 2022. We are here in Los Angeles, California. Okay, this is David de los Reyes. I am now on topic number 18 or lesson number 18 under integral calculus on my channel. So for today, I will be discussing evaluation problems of a trigonometric function that involves tangent only. Tangent only. Okay, let's proceed so we don't waste time. Okay. The topic for today is tangent only evaluation problems. I will give you example number 1 for today. Example number 1. The integral tangent to the 6 of theta, differential theta. Tangent only. Okay. Yesterday we are done with the second. So for today we will do tangent. Okay, proceeding with the solution of this systematically. Okay. The integral of tangent to the 6 of theta, differential theta. This can be written as tangent to the 4th of theta, tangent to the 2nd power of theta, differential theta. 4 plus 2 is 6. So we just rewrite it in another form. Okay. Next. This will be the integral of tangent to the 4th of theta. We will replace this tangent square of theta by its equivalent in terms of secant. And that is actually secant square of theta minus 1. Because 1 plus tangent square is secant square. Therefore, tangent square is secant square of theta minus 1. Differential theta. Okay. Expanding. This should be equal to the integral tangent to the 4th of theta, secant square of theta, differential theta. That's the first term after the expansion. Next term will be tangent to the 4th of theta times minus 1 times differential theta. This should be equal to the integral. Tangent to the 4th is tangent square, quantity square, differential theta. Okay? It's a little bit, it's not complicated, but the simplification will be long, so I will present a systematic solution for you not to maximize your horizontal writing, right? You should maximize your vertical writing. So I will let A equal to the first one and B equal to the second one. Meaning, we will evaluate the value of A and B, and our solution should be vertically. We maximize our space vertically, not horizontally, so we don't consume the whole magnetic board. Okay, let's compute for the value of A. A is actually equal to the integral. It is this. We will solve for A separately, and we will maximize our space vertically, okay, not horizontally. So this will be tangent of theta to the 4th, secant square of theta, differential theta. This is integrable, right? This is under the power formula. So I will let U equal to tangent of theta. Du will be, the derivative of tangent is secant square. So du will be secant square of theta, differential theta. It is exact. Exact. Right? So if the value of du is exact, this now falls under the integral of u to the n du. And that is actually u to the n plus 1 over n plus 1. N is 4. So tangent of theta to raise to the 4 plus 1, which is 5, all over 5. All over 5, or simply 1 over 5, tangent to the 5th of theta plus c1. That's the integral of the value of A. We do it separately. Okay? we do it separately. So we maximize our space vertically and we don't consume the blackboard or the magnetic board horizontally. Okay, let's try to compute for the value of B. The value of B is with the negative sign, the integral of tangent square of theta quantity square differential theta. We represent that as B. So actually, it's just a matter of representation. If you are taking the board exams and you do this, the examiner will understand your solutions. Okay, we will compute for the value of B separately, including the proper sign. There's a negative sign over here, right? So B equal to open quantity, negative sign, close quantity, the integral tangent square of theta quantity square differential theta. Okay? And this can be written as tangent square of theta quantity square can be written as tangent square of theta times tangent square of theta. Then try to replace the second value of tangent square of theta by its equivalent in terms of secant, and that is actually secant square of theta minus 1, close quantity differential theta. Then try to expand, but carry the proper sign, negative, because later on, if you don't carry this one as you move downward, you will be wrong. Okay, so I still maintain the negative sign outside, the integral of, we expand now. Tangent square secant square is tangent square secant square, differential theta. Second term will be tangent square of theta times minus 1, so actually minus tangent square of theta, differential theta. Okay? For the first one, this is now integrable. It falls under the power formula. Okay? I will not place the value of u and du here. I will just say it verbally. We lack space. The value of u here is tangent of theta. Du is secant square of theta differential theta. It is exact. So actually the integral of this falls under the power formula. Okay? So I will now integrate this one with the proper sign. Tangent 2 plus 1 is 3 all over 3 or negative 1/3 tangent cube of theta. Our only problem now is the integral of this second two terms on the right. What will happen? Minus times minus, this will be plus the integral secant square of theta differential theta. Okay? Minus 1 minus this minus, it will still be minus. Because a minus in the minus will be plus preceded by negative sign, that will still be minus. So 1 times differential theta is the integral of differential theta. And these are now also both integrable. Right? This is tangent. This is just pure differential. So to bring out the value of B, this will now be negative 1/3 tangent cube of theta. The integral of this is just simply tangent of theta. Okay? The integral of the differential of theta is just negative theta plus constant C2. That's the value of B. Okay? So as a final answer, therefore, the integral of tangent to the 6 of 6 theta differential theta equal to, we will copy the value of A, okay, 1/5 tangent to the 5th of theta, okay, minus 1/3 tangent cube of theta plus tangent of theta, tangent of theta, we are lacking something over here. Sorry for that one. This is minus theta plus C1 plus C2. Okay? Because there is a C1 here, right? We must have to include that one. And there is a C2 here. We must have to include that one. So the final answer is actually 1/5 tangent to the 5th of theta minus 1/3 tangent cube of theta plus tangent of theta minus theta plus C1 or C2, or we will let the value of C1 and C2 to be simply C. So our final answer will be this is plus C. This is minus theta. That's the final answer. The value of C1 and C2, we will just simply put it capital letter C. It's a pure constant. Therefore, the final answer will be 1/5. I will repeat it for the last time. 1/5 tangent to the 5 of theta minus 1/3 tangent cube of theta plus tangent of theta minus theta plus C. That's the final answer. Okay? You see how our solution was systematic? We maximize our space vertically, but we don't consume our space horizontally, so the board will be enough. Okay? You say? Oh, that's example number 1. Okay, let's proceed with example number 2. Not so complicated. Number 1, it's also complicated, but a little bit longer than the second one. Okay, I will present example number 2. Still under tangent only. The integral of tangent square of 2/3 x dx. The angle is 2/3 x. To integrate this one, we must have to bring out an identity that relates to tangent square. And actually, from my previous discussions before proceeding with evaluation, I gave you identities. And one of those identities is 1 plus tangent square of alpha equal to secant square of alpha. From my listing, it's theta. You could replace that one. Okay? Theta, alpha, beta, gamma, it doesn't matter. Okay? As long as the relation is correct. So, we let 1 plus tangent square of alpha equal to secant square of alpha. That's a standard identity in terms of tangent and secant. But if alpha is 2/3 x, because the given problem, the angle is not alpha, it is 2/3 x. If we replace alpha by 2/3 x, okay, simplifying this one further, 1 plus tangent square of 2/3 x equal to secant square of 2/3 x. Solving for tangent square of 2/3 x, it will be secant square of 2/3 x minus 1. We transpose this on the right. Okay? Therefore, the integral of tangent square of 2/3 x dx equal to the integral of secant square of 2/3 x minus 1 close bracket differential dx. After replacing the value of the tangent in terms of secant, the right hand side now is now integrable. There is an integral for a secant square. So we verify the value of u. U is 2/3 x, du is 2/3 x. It is not exact. Okay? We are missing 2/3, okay, on the differential. So we will introduce the reciprocal of this outside. So this will now be equal to 3/2 the integral secant square of 2/3 x. The complete differential as per verification, it is 2/3 dx. Minus 1 times dx, the integral, it is just simply x. Okay? Let's see. So as a final answer, therefore now the integral of secant square, tangent square of 2/3 x dx equal to 3/2 tangent of 2/3 x minus x plus c. That's the final answer. It's easy, right? As you notice it, the only function is tangent only. That's why our discussion for this afternoon is only tangent only. Okay? I think that's just more than good enough example for today for the tangent only. Okay? If you've got any problem, just bring out your comment. If you like it, please click like. If you want to share it, please click share. And if you want to subscribe to my channel, please click subscribe. Tomorrow we will be discussing, or the next topic or the next lesson will be trigonometric functions that involve cosecant and cotangent as a whole exclusively. Okay? So actually, if you notice it, we do our study gradually. Okay? We got all the topics upward. So we are not missing something. Okay. Good afternoon, Los Angeles. Thank you.